Hi everybody, welcome to another Chats with Chaudhry. I hope you're safe and well. Today I'm delighted to be joined by Dimitris Argyropoulos. I hope I got pronounced that right, Dimitris, who is the that's a good start. Who's the NMR business manager for ACD Labs. And today we're going to be talking about some of the common challenges researchers and scientists face when using NMR for whole structure characterization. So Dimitris, how are you, my friend?
I'm fine. Thank you very much for giving us the opportunity to talk and discuss about NMR. Yes.
That's brilliant. Well, look, thank you very much for taking time out to talk to me, Dimitris. But before we start talking about NMR and the challenges people face, could you give people a quick background on ACD Labs and on yourself as well? That'd be great.
Okay, sure. So ACD Labs is a software company that was founded 26 years ago in Toronto, and we have sales offices in Toronto, in the UK, and in Germany, and in China. And we cover all the other regions through these offices or through agents. We are developing software for chemists. We have mainly two product lines. We have what we refer to as the Spectrus product line, which is software for processing all sorts of spectroscopy data, and not only NMR. And we also have the Percepta line, which is software for predicting physicochemical properties of compounds. In the last few years, we are expanding into more enterprise solutions with our Luminata and Catalyst offerings for impurity resource management and process chemistry management. The company, is, as I said, 26 years old. We have close to 200 employees by now, which is quite impressive for somebody doing only software. It's interesting that the company started with NMR 26 years ago. So the first products were a carbon NMR predictor. There was a log-P predictor and a UPAC naming, but expanded since quite a bit. Now, regarding myself, despite the name, I was actually born in the UK, but then my parents decided to move to Greece. So I grew up in Greece and I studied there. And my first job was as an application chemist at Varian in the applications lab in Darmstadt in Germany. After a few years, I moved to a new applications lab that Varian was opening in Oxford in the UK. And I have stayed there ever since. Now in 2014, Varian, who had already been bought by Agilent, decided to exit the NMR market. So since 2015, I've been working for ACD Labs, initially as an application scientist, and the past 4 years now as the NMR business manager.
Fantastic. So you know NMR then, that's the key thing here.
I know NMR.
Brilliant. So my first question is a really basic question, is what is NMR and why is it useful for whole structure characterization?
So NMR stands for nuclear magnetic resonance. Okay, and what NMR does is it can give information about the specific sites, the specific atoms of a chemical compound. It is the only technique that can do that for the whole of the molecule, together with X-ray crystallography. The advantage of NMR over X-ray crystallography is that it's extremely fast. You don't need a single crystal. You can just put your compound in a tube, add a little bit of solvent, put it in the NMR instrument, and within minutes, you start having useful information. Okay, so NMR is the only technique that can give information about the structure in the liquid state. It's the only technique that can give information about the units in the molecule, the atoms, but also how they are connected together. You will get information about the characteristic groups, for example, if you use infrared spectroscopy. But infrared spectroscopy will only tell you that you have a carbonyl, you have a methyl, or whatever. NMR will tell you that you have a carbonyl and a methyl, and it will tell you whether they are connected or not. So that's the differentiating factor there.
Fantastic. Well, thank you for that thorough overview. So in terms of when you're using NMR, what are sort of the main issues and challenges researchers face when they're using NMR for different applications?
So the number one challenge of NMR is its inherently low sensitivity.
Right.
Okay, so you need to have a significant amount of sampling there to get information. This has been alleviated in the recent years with the development of more sensitive spectrometers, higher field spectrometers, and with the development of more sensitive probes and techniques. So this is not that much of an issue as it used to be, let's say, 20, 30 years ago. The main problem these days is managing the information that you get.
Right.
And sometimes this can be quite overwhelming. It's probably fine if you record, spectra of a single compound a day or a handful of samples a day, and you could interpret it. But after a bit, it gets a little bit intimidating. It's a lot of information coming in, and people will have problems, managing all that. Moreover, it's not necessarily that you are looking always for the answer for the answer to the same question. You are interested to find out what is in your NMR cube, and you may have a good idea of what is in there. You may have no idea at all, and you may know, just a little bit, or you may know, that it's something that somebody else knows, but you don't. So this all has to do with the type of application that you are doing. So if you are doing, for example, natural product chemistry, and you have spent a lot of time isolating something new, then you probably have no idea what is in there. Right. And you use a different set of tools. If you are doing synthetic chemistry and you did a particular reaction, you know what you had, you know your reaction, you know what you expect. So you're looking to see whether what you were planning to actually has happened.
Right.
If you are doing competitive analysis and you have a competitor's product and you want to see what they have in there, then yeah, you know more or less what it is, but you want to find the specific details, the additives and these things. If you're doing counterfeit analysis in pharma, very important, then you again want to know what exactly did they put in there and how do they are marketing it, with the names that they do. So it's quite a bit of challenges there, and individuals usually can handle up to a few per day. If they have more, then it starts getting difficult. And also the other situation is that people will have will be biased towards a particular answer. I mean, think of the synthetic chemist who has done the reaction, and they expect that it went the way it went. And if they see something that's a little bit off, the initial reaction is, yeah, hey, no, maybe it should be like that, and you try to fit the data to what you expect because you are biased to get what you wanted. Okay.
Right. Okay. So how can users overcome those challenges, and how can ACD Labs help?
Yeah. So the way to overcome these challenges is to get a second opinion on these things, and the second opinion can be a colleague of yours, or it can be software that you use to do the analysis. If you use software like software from ACD Labs, then the software is not biased. Okay, the software will give you the answer, which would be, let's say, completely independent, completely unbiased, completely neutral. ACD Labs has lots of tools to help throughout all these steps. So we have tools to help people find the possible structures of known compounds. We have tools to help people verify whether the structure that is presented is what they are expecting to have. We have tools that can suggest alternative structures if what you proposed is not quite the one that appears to be the one.
Right.
And we also have tools to do the full structure elucidation if you are, as to say, completely lost in the woods and don't know what's going on in there.
Right. Okay. So basically, you've got a whole portfolio and a suite of different solutions then to help people across.
Yes. Yes.
Right. Okay. So if people want to know more information in terms of the solutions you've got and how to meet those challenges, where can they get more information?
Yeah, so to begin with, there is a lot of information on our website. And also next week, we will have a webinar talking about this and answering the question, what's in my NMR cube? This will be the first part of a series of webinars answering this question. It's next week, and the next one would be in another month's time or so.
Perfect. Okay, so I will put details of the webinar above this video so people can register for the webinar and so on. And you mentioned the website address as well. You've also got quite a lot of white papers, haven't you? And application notes in terms of the topic.
Yes, they are all on our website, the applications notes and past webinars that we did, informational videos, all these things are there.
Fantastic. All right. Well, thanks for taking time up, because I know you have another meeting coming up. So, Dimitris, thank you very much for your time. That's been really interesting. If people would like to know more, they can obviously go to the ACD Labs website. The link, as I said, will be above the video. They can register for the webinar series, which starts, I think, next week. And again, the details will be above the video. Or I'm sure they can message you directly as well, can't they, Dimitris?
Absolutely, yes, definitely.
Fantastic. So all that stuff he says, Dimitris, thank you for taking time out to do this for me. I know this is the first time you're doing it, so I appreciate you answering those questions. It's never easy when you haven't done it for the first time, so thank you very much for that.
Thank you very much for giving us the opportunity to do this, and thanks for setting it up.
That's a pleasure. So I wish you, your loved ones, a fantastic, happy, successful 2021. To everyone watching, I hope you found that useful. I hope you can get in touch with Dimitris or check out the webinar. If you've got any issues around NMRs, I'm sure he'll be happy to help. And until next time, as always, stay well and stay safe. Thanks. Bye-bye.